Hi, welcome to your Unit 1 Counting Methods 1.3 Factorials. Factorials are so fun, so let's get started. You can do these on your calculator, so if you have a graphing calculator or even your iPhone, you are able to solve these problems. For any counting number given, or number n, the quantity n factorial is given by n factorial, that's what this guy right here means. N times n minus 1 times n minus 2 times 2 times 1. What does that mean to you? Let's go ahead and look at it. For example, I have 3 factorial. So this would be 3 times 2 times 1, which is 6. 6 factorial, 6 times 5 times 4, 3, 2, 1. So I get... I do that in my calculator. 6 times 5 times 4 times 3 times 2 is 720. 6 minus 3. I do what's inside my parentheses first. So that's 3 factorial, which we already know from this up here is 6. And then down here I have 6 factorial minus 3 factorial. So I take my 6 factorial, I have to do that first, minus my 3 factorial, which is 6. 720 minus 6 is 714. 6 factorial divided by 3 factorial. Now this one's different because I'm dividing. So I have my 6 times 5, 4, 3, 2, 1 over 3 times 2 times 1. What do you notice is on top and bottom? 3, 2, 1. I'm going to cancel those out, which is kind of exciting. So I do 6 times 5 is 30, times 4 is 120. This one's written differently. Now this one says you do 6 factorial first, and then you divide by 3 factorial. So 6 factorial, 720, divided by 3, 2, 1, so 6. Put that in my calculator, and I get 120. So 15 factorial, that's next. 15 times 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. It's going to be a really big number. So if you are using your iPhone or anything like that, if you flip it sideways and go to the very left-hand side, there's an X with a exclamation mark. So I'm going to type in 15, the exclamation mark. Okay, wait for it. It's a really big number. 1307 674 368 000. So this is millions, billions, trillions, quadrillions. So 1 quadrillion, 307 trillion, 674 billion, 368 million, really big. 100 factorial is going to probably break my calculator, but it's really big. And I will post an extra video showing an actual graphing calculator and how you can do it on a graphing calculator as well. 0 factorial is always 1, always. When finding the total number of ways to arrange a given number, we always use a factorial. It makes our lives a little bit easier. Here's an example. Erica has 7 ways to write, 7 essays to write for her English portfolio. And how many different ways can she arrange them? So if I have 7 essays I have to write, I want to write my first essay. So there's 7 of them. I can choose from 7. And then there's 6, 5, 4, 3, 2, 1. So I'm going to do 7 factorial in my calculator. Or by hand, you can always multiply those out as well. It's up to you. So 7 factorial. I I get 5,040. Okay. Next problem. Lynn is taking 13 preschoolers to the park. How many ways can the children line up in single file to board the van? So you have your 13 spots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. I do my 13 factorial in my calculator. And I get, looks like 6,227,020,800 different ways that she can line them up. What if there are two objects that are the same? So there's 2 oranges, 3 marbles, 2 in the same book. What do we do? This is called a distinguishable arrangement. So we see this a lot with letters. So this is what it'll be like on your test as well. You count up how many total numbers there are, letters there are. So 1, 2, 3, 4, 5, 6, 7, 8. There are 8 letters, so we do 8 factorial. Then I count up any repeats. So I have 1, 2, 3 E's, and I have 1, 2, 2 S's. So I do 3 factorial times 2 factorial on bottom. And then I divide. 8 factorial divided by these. So 8, 7, 6, 5, 4, 3, 2, 1. I'm all about simplifying as much as possible because I don't want to multiply big numbers. I'd rather multiply smaller numbers if possible. I notice that I have a 3, 2, 1 here and a 3, 2, 1 here. Cross those out. So now I just have 8 times 7 times 6 times 5 times 4 on top. And I get 6,720. And I'm dividing that by 2. So there are 3,360 ways. And then nominee, I'm going to go about and do the same process. So go ahead and pause the video and, so you can get some practice working on these without me going through it first, and then you can check your work. So now I count 1, 2, 3, 4, 5, 6, 7, factorial on top, and on bottom I have 2 N's and 2 E's. So I do 2 factorial and 2 factorial. 8, oh, sorry. Looking at the top problem, 6, 5, 4, 3, 2, 1, over 2, 1, 2, 1. I notice I have this on top and bottom. So 7 times 6 times 5 times 4 times 3, and I'm dividing that by 2. I get 2,730. And that's it for your notes. I can tell you right now distinguishable arrangements are on your test, and so are factorials. So please make sure that you are practicing these in your homework, and if you have any questions, go ahead and let me know. Have a great day.